despite setting up this variable speed thing in hopes that it will help reduce the overall load on the charging system, we have still overwhelmed the charging system and what it can do at idle. So now we're going to look at either a 200 or a 250 amp alternator, or changing the pulley size on the crank, or, well, we really can't change the pulley on the alternator. The pulley on the alternator is already, I think, about as small as you're going to get for any V-belt. So it's probably one of those two. We can use our Snap-on low amp probe, and with our Snap-on Veris Edge that has a lab scope, and we can understand exactly at what point of output this alternator overwhelms the charging system and starts to raise above 13 volts. And we can use this to come back and understand the alternator that we need. So for now, the very next step is going to be to get the Snap-on lab scope side of Veris Edge connected with the low amp probe around the charge wire on the alternator. Let's make that happen. This is the Snap-on Veris Edge. This is a Windows 7 based scan tool, and it has a built-in 4-channel lab scope. There's one better than this that Snap-on makes that is Windows 10 based, and that is the Zeus. This tool I've had for a lot of years. I actually bought it brand new when it first came out in 2015. So it's getting pretty old now, but at least it's paid off. I keep it updated. It's on 24.2 software, and we can go to scope multimeter, and we can go to lab scope, ignition scope, graphing meter, digital meter, presets, reset all functions. We're going to do lab scope, 4-channel volts, low amps, low amps, low amps, ignition probe, 10 psi, 100 psi, or 100 psi vacuum, 100 psi pressure, 500 psi pressure, 500 psi pressure, or 5,000 psi pressure. These are the ranges that we can choose. We will choose I think we want to do low amps 20. And we'll leave that there. The next step, of course, is going to be to get our Snap-on low amp probe set to the right setting, and then clamped around the charge cable, leaving the alternator. Then we'll start the car, we'll turn on all the loads, and we'll understand exactly how many amps are flowing down this charge wire when the alternator is overwhelmed and not able to put out full battery voltage. And then we'll bring the idle up until the point to where it just starts charging at 13 volts, and we'll see how many amps we're flowing, and we'll understand exactly how many amps we need to have at idle to support proper charging. Unfortunately, it's been a while since I've used my Snap-on low amp probe. So the Snap-on low amp probe, because it has different settings and a calibration to it, we have to, it has a battery. It's got a 9-volt battery in it. So there's 3 screws that are right here. Boom, 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 little Phillips head screws. You take the screws out, the low amp probe comes apart without too much fuss. And then there's a 9-volt battery right in here. This 9-volt battery is probably, I don't know, 5, 8 years old. There. Oh. Oh no. Wow. That connection has seen better days, huh? Can you guys see that? We'll take some oiled emery cloth and clean that up. We'll put a fresh battery on it and see if it makes a connection, or if we have to solder in a new 9-volt battery connector. All right, I'm gonna go get that battery. I'll be right back.